start with section 2.7, which is the important part of this section is how to graph the piecewise function. We're gonna example. Now let's start with the concept symmetric. Symmetric over respect to the y. We have symmetric with respect to the x. We have symmetric to the origin point. The graph, single graph here, show you how it's looking like. So you can say here is negative y, y, negative x, here is x. I'll show you so you can visualize what's the meaning of symmetric. So if you have this graph, let's say here. Actually, exactly. This is called symmetric over y. Why? Because this side is similar to this side. We're gonna call it symmetric over the y-axis. This side is similar to this side. That's called symmetric over y-axis. Now I'm gonna do another graph here. Y, y, x, x. You have this graph. Now this one is symmetric over x-axis because this side is similar to this side. So this is symmetric over x-axis. There is another graph. What is this one? Not similar to the other side, so it's not symmetric over y. It's not symmetric over x. It's symmetric over the origin point, which is the point 0, 0. This side similar to this side. Is that okay? So when you look at the graph, you can tell which x or y of the origin. What about if they give you a function? They ask you to figure out the symmetric over x or y of the origin point. You have to do these steps. Symmetric with respect to the y, if we substitute negative x with x, and the result should be equivalent to the equations. So, okay? We're going to do an example. Each example, we're going to do symmetric with x, y, or the origin, so we can figure out. Symmetric with x, substitute negative y with y. Substitute negative y for y, and the result should be equivalent to the equations. Is that okay? What about the origin? We have to satisfy both. Negative x for x, and substitute negative y for y, and the result should be equivalent to the equations. Is that okay? We're going to do an example so we can figure out how we're going to substitute that. What says how? Let's start with the y. So I'm going to check symmetric with y-axis. What are they telling you with y-axis? With respect to the y, we have to substitute negative x for x. That means I'm going to put instead of the x, y equal what? Negative x, and here is the cube. Okay? I'm just going to take out the x and put negative x. So now, can I simplify this? That means y equal what? Negative x cubed is going to be negative x times negative x times negative x. What's the result is going to be? Negative x cubed. Is this the result similar to the original equations? What does that mean? Not symmetric over x. Okay. Okay, not that much hard. We do the second one. Now this is with y-axis. Now let's check with x-axis. What we're gonna do if we check to the x-axis? We're gonna substitute negative y with 4y. So here's the original equations. So it's going to be what? I'm gonna put, instead of y, I'm gonna put negative y equal x cubed. Is that okay? Now, how are we gonna solve it for y? How are we gonna solve this one for y? I need to solve it for y. I need to keep y by itself.
Divided by the negative.
Because there's negative one here, so I'm gonna divide both sides by negative sign, by negative one. So divide this one by negative one, divide this one by negative one. That's mean y equal negative x cubed. Is this one similar to this one? This is the original equations, right? No. It's not symmetric over. This is not x minus x. It's x axis. That's how we're gonna write it down. Okay. Now the third one, how are we gonna do it? Do it both. Substitute the origin. We're gonna substitute for both negative sign. They're telling you substitute what? Negative x for x and negative y for y. So how is it going to be? On the origin, over the origin, we're going to substitute negative y here and negative x here. So it'll be negative y equal negative x cubed. Okay. Substitute negative y here and substitute negative x here. Let's simplify it. This is negative y equal negative x cubed, right? Yes or no? Now divide both sides by negative. It's going to be y equal what? Is that similar to the origin? To the original equations? So what's that mean? That means it's symmetric only on the original point. You got it? You can know. This is 3 steps. We solved only one example and we did 3 steps. How are we going to do that? First of all, this is the original equations. Number 1, I'm going to find the same thing. Symmetric over y axis. What do I have to do? Substitute negative x for x. That's mean I'm going to put negative here. So y is going to be negative x, right? Square plus 5. Is that okay? I'm just going to take out the x and put negative x. Now negative x squared is going to be x squared, right? Plus 5. Is this one similar to this one? That's mean what? It's symmetric over y axis. The first one. Let's check. Circle. I have to keep going. I will just check our x-axis. You substitute negative y instead of y. I'm going to be negative y for what? Square plus 5. Now we need to solve it for y. So what I have to do? Divide both sides by. If I say negative 1 here, negative 1 here, that means y is going to be equal negative x squared, right? Minus 5. Similar to the original. What does that mean? It's not symmetric. Not x-axis. Down from the second part. The third one, symmetric over the origin. What we're gonna do, substitute negative y for y and negative x for x. That's mean the origin is going to be negative y equal negative x squared plus 5. Yes or no? Now it's going to be negative y equal what? Negative x squared plus 5. Now we need to solve it for y. Divide both sides by negative 1. So it's going to be negative x squared minus 5. Is that similar to the original? So it's not symmetric. Origin. Is that okay? Question?
Solve the parentheses first.
Which one? Talk about this one?
Yeah. And then you find
Yes, because negative x, I need to simplify it, which means negative x times negative x is going to be x squared. Then I'm going to solve it for y, which is divide both sides by negative. Okay? Is that okay so far? And with respect to the y, because we need to substitute x. With the y, we're going to substitute the x. The same thing, always follow the steps. For the y-axis, we're going to substitute, and instead of the x, we're going to put negative x. So negative x squared plus, keep the y. There is the other side. I'm not going to care about the other side. Now, negative x squared, right? Plus, there is y plus 1 squared equal 4, which is this one similar to the origin. Which means this is symmetric over y-x. Hard. What about like how we're gonna but just substitute negative x instead of each x. Now the second part, what do you think? Over x-axis, we're gonna substitute negative y here. There is x squared plus maybe negative y plus 1 squared. Yes or no? Now what do you think?
No. In order to solve it, you gotta FOIL it, right? And if you FOIL it, you're gonna get a different answer.
Yes. Because if you need to solve it, you have to FOIL this one. And when you FOIL this one, it's not gonna be the same, the original one.
Or take you the
There
same.
is negative y.
Yeah.
So that's it. You don't have to mess it up. If you FOIL this part and FOIL this part, are you going to get the same? No, that's it. You don't have to overthink it. Oh, I'm gonna solve it for y. No. That's the problem is going to be here. Negative y, if you FOIL it, 100% is not going to be the same when you FOIL this part. So you're just gonna say, okay, no, not symmetric over x-axis. So by practicing, you're gonna figure out by just looking to the question. But you have to know which one is symmetric to which one. Now for the origin, we're gonna do substitute negative x here and negative y here. So give me negative x squared plus negative y plus 1 squared equal 4. This side is going to be x squared plus negative y plus 1 squared equal 4. Now, we get the same situation. This one, if you FOIL it, it's not going to be the same the original one. So in this case, it's not symmetric over not symmetric. The origin, which is the 0, 0. How about the last one? Step by step. How are we gonna get symmetric over y-axis? Y-axis. We're gonna replace negative x here. So y equal negative x minus 2, right? This means y equal the absolute value of negative x.
Regular X.
It's positive x minus 2. So that means this is the same original. No, what are you gonna say? Yes, because there's two options here. So this is what's going to be. Yes, symmetric over y-axis. Number 2. X axis. What do you think? Symmetric over x axis or no? Yeah, substitute what?
Y for negative Y.
Y. We need to find it for y. It's going to be negative y equal. Now, what about if you solve it for y and divide it by what? By negative 1. Whole thing here by negative 1, which is going to be y equal. You can say because there is 1 here, so it's kind of like this. If you just look to this number, it's negative, and here is what? Positive, so it's not. Same thing. The last one. Substitute negative y here and negative x here. Going to be negative y equal what? Negative x minus 2. Also, when you solve it, this is going to be negative y equal x minus 2. When you divide by negative 1, going to be what? Negative x plus 2. By just looking to this number, maybe the same. So it's not symmetric over. Is that hard? No. There's another way. Let's see. So even function, what am I telling you? Even function, the function is going to be even if you substitute negative x for x, the result is going to be what? The result is going to be the original function. Similar to what? What do you think? Similar to the y. The y-axis, symmetric over y-axis. Symmetric over y-axis, when we substitute negative x for x, the result should be equal to the original function, right? That's what we're doing here. We're telling you f to the negative x, that means substitute negative x for x, the result should be what? So you can write down here is similar to the symmetric over y. Did they mention that in the notes? They mentioned that in the notes, right? What are they telling you on the notes?
Back to the Y-axis.
So that's respect to the y-axis. So the same way, when we need to find the y-axis, we're going to substitute what? Negative x for x. So I'm going to check this one. I'm going to check if it's even or odd. I'm going to start with even. I'm going to substitute negative x here and negative x here. So I'm going to say f to the negative x equal negative x to the power 4 minus negative x to the power 2 plus 2. Is that okay? Now, go ahead, simplify it. Negative 4, negative x to the power 4 is going to be what? X to the power 4 minus negative x squared plus 2. Is this one equal to the original? See, we started from negative and we add to the original. So what's that mean? This is even function. That's it. On the same time, yes, it's symmetric over the y-axis. But our goal is to find even function or odd. that okay? Next one. Even or odd. Maybe it's odd, maybe it's not. Now let's check. I plug in negative x here. So f to the negative x is going to be what? Negative x to the power 3 minus, there is negative x plus a 3. Negative x cubed, yes or no? Negative times negative. Plus a 3. This is similar to the original? Yes or no? So this is not. So not even. Let's check the odd. What is telling you the odd? The odd function, if you plug in negative x, the result should be what? Negative f of x. Can you check that there? You want to do it again? Use the same one. Do it again. It's the same function. So if I plug in negative x in the function, it's going to be negative x cubed minus negative x plus a 3. Is it okay? So cool. Negative x cubed plus x plus a 3. Is that okay? Now, if I took negative sign as a common, what's the left? X cubed minus x minus a 3. This one is equal negative f of x. There is the negative sign. This one similar to the original function. This one similar to the original function.
No, because as a.
What's the negative 3?
Yeah.
So in this case, you see negative f of x. So it's not similar, not equal to negative. So it's not odd functions.
We just factored the
The negative sign, yes. When you factor the negative sign, it should be the left here should be equal to the original. In this case, it's not. It's the negative 3. Is that okay? You get the idea? Kind of. Next example. You know that the even function is symmetric to the y-axis. But the odd function is symmetric to the origin point. Okay. Now let's check here. What about this example? We're gonna start checking if it's even function. So I'm gonna say f to the negative x equal what? It's negative x cubed minus, and here is negative x. So don't confuse yourself. Write down everything, but put parentheses every time you plug in negative x. Plug in negative x here, I'm gonna put parentheses, plug in negative x here, put parentheses. Now go ahead, simplify it. This one is what? Negative x cubed. This one is what? Plus x. So from the result, tell me, it's even or odd function? First of all, this one similar to the original. So what's that mean? It's not even.
Oh, it's gonna be odd.
It's gonna be odd. But first of all, I'm gonna check. This one similar to the origin? No. So it's not even. So I don't have to do the process again like this example. No, I'm gonna check. Can I take negative sign out? So if I took negative sign out, what's the left? X cubed minus x. The left here similar to the origin, which is mean negative f of x. So in this case, this is what? Odd function. Okay. Now let's check here. The next two examples, I did kind of similar to it here. keep in your mind, symmetric over y-axis is even or odd? It's even. So every time when it's symmetric over y-axis, it's even function. So this one symmetric over y-axis, this side similar to this one. So it's symmetric over y-axis. That means this 100% is going to be even function. Okay. Now the other one. The other one is symmetric over y-axis. No, it's symmetric over the origin. This one similar to this one. Let me check the origin graph. Maybe. Yes. Go to the original graph. You have it. This one is not accurate. But if you look to the graph, you have this one here, this one here, this one here, right? So what's that mean?
Backwards.
Yeah, because it's not accurate, the graph here. But the one you have it is accurate. You see? This one here, this one here, the small here is here. So it's symmetric over what? The origin point. So in this case is what? 12.
Odd.
This is even on the top, and the one here is odd function. A piecewise function, which is a function has more than one piece. 3 pieces, could be 4 pieces. It depends about the interval. So check here, that's the important part, the conditions here. They're telling you when x less than 0, what's that mean less than 0? That means negative numbers. When x less, every time you see an x less than 0, use this piece to evaluate. Every time you see x greater than or equal to the 0, use this piece. Is that hard? They're just telling you like, okay, when you have this condition, use this part. When you have this condition, use this part. That's it. So to evaluate, that means we have to find the value of y. F to the -1. How much the value of x here? Here.
Smaller than 0.
No, here. Oh, how much the value of x here? -1. Here's the value of x. This is f of x. That means the value of x here, which is this one. So x is -1. Which piece I'm going to use? This piece. So I'm going to plug in -1 here. So it's going to be -1 squared plus 1. -1 squared, 1 plus 1. That's it. The second piece, how much the value of x? And then the second one. The value of x is 5. 5 exists in this condition or here? Second condition. So it'll be 5 minus 1. 5 minus 1, which is equal 4. That's it. The third one, 0. X equals 0 exists here or here with the equal sign, which is so going to be 0 minus 1, which is equal. That have to evaluate. Let's check here. First of all, it's piecewise function. We have 3 pieces. Here, not confused. All the numbers between what?
2 and 4.
2 and 4. You got the idea? Including the 2 and 4. Why? Because the equal sign. That means it's 2, 3, 4. Got it? Because there's equal sign. Sometimes you're gonna find that the equal sign is here. The first piece, all the numbers less than 2. The last piece, all the numbers greater than 4. Now, how much the value of x? 1 exists where? On the first piece. So I'm gonna plug in 1 here. So it's gonna be 1 squared plus 3, which is equal 4. The second piece, 4. Here or here?
Middle one.
So how much the result? That's it.
Well, that was like 4 times 7 or something.
No. Because there is no x here. That's a good point. If there is an x here, that's when you're gonna plug in 4 where? Here, which is 7 times x, 7 times 4. Okay? But there is no x here. That's mean all the numbers
When there are 7.
between 2 and 4, the result is what? 7. Okay? So you're gonna put just 7. Now, 3 exists where? Also is going to be what? Also 7. 5, which is on the last piece, with 2 times 5 minus 1, which is equal. Is that okay? Of cake? So they're gonna ask you, graph this function. And this is piecewise function. The first thing I'm going to do, create table. The table how I'm gonna create it. Write down x, and put the y here, and I need to find what? The point x, y to graph. Is that okay? Okay. Now, it's piecewise function. That means there is a graph for each piece. Is that okay? And sometimes these two pieces is not connected. Sometimes the pieces is connected. So it depends. So in this case, I'm gonna put dashed line here. See, I put dashed line. I'm gonna graph the first piece here, and the second piece is going to be. Okay, so far. Here's the important part, the dashed line. Now, what's the number here? What's the number here? Always going to be the same. The end of the interval always going to be the same. All the numbers less than 2, all the numbers greater than or equal to. So you see this, the 2 is the start point. So you see the dashed line? I'm gonna put 2 here, I'm gonna put 2 here. Is that okay? Now, is there a equal sign? There's a equal sign here. There's a equal sign here? No. So the start point here is open circle. Because there's no equal sign. There's equal sign on the second part. The start point here is going to be what? Closed circle. Is that okay so far? Now let's go back to the condition. Where is the start point? This is the start point, right down here. These 2 points is the start point. To graph this piece, I'm gonna start from this point. To graph the second piece, I'm going to start from this point. Is that okay? Now let's go back to the condition. On this piece, what's the condition?
Smaller than 2.
Here is the 2. I need another number less than 2. 1, 0. Let's choose 0. It doesn't matter. 0, -1, but don't choose -100. The main thing, he said 1, I chose 0 because 0 is easier. You can choose -1, but if you choose 1, it's still the same solution. Because the important one here is this point, not this one. And I'm going to show you why. Now, with this piece, this one goes with the second piece. What's the condition?
2 or bigger.
We're not going to choose 2 because we have to. We need another number. 3, 4. Let's choose 4. Is that okay? Is that okay so far? So I have 2 points for the first piece. I have 2 points for the second piece. Go ahead. Plug in this point, these 2 points on the first piece. So then we have times 0 plus 1. It's equal what? 1. So this point is going to be 0 and Plug in 2. Half times 2 plus 1. Half times 2 is 1 plus 1, 2. So this point is going to be. Okay. Same thing. Plug in these 2 points where the second piece. Careful. I'm not gonna plug in these 2 points on the first one. On the second piece. So plug in 2 here. That's mean -2 minus 1 equal -3. So this piece is going to be 2 -3. Plug in 4. So it'll be -4 minus 1 equal. So this piece is going to be 4 and -5. Okay, so far? Yes or no? That's. Now let's check. If I need to graph the first piece, which one is the start point? 2 and 2 is the start point. So I'm gonna go ahead. 1, 2, 1, 2. So here's the start point. It's open circle, so I'm gonna put open circle. Is that okay? Now, where's the second point? This one. So I'm graphing this piece. Do not start a graph in this one, it's gonna be wrong. This is the start point, and you're gonna go to the second point. Is that okay? Start point, and you're gonna go to the second point, okay? Because we need to grab this piece. Second point is 0, 1. Where is 0, 1? 0 and 1. So here is the second piece. That means the graph going from where? Start point, the second point, and keep going down. Is that okay? That's why I'm telling you, that's the important point. I don't care about which point you're gonna choose here. 0, -1, -5, -10. If you choose -10, it's going to be here. It's going to be down like this. But the graph is still going down. So the purpose of the second point is to give you the direction. The direction of this piece going where? Going here, going here, here, we don't know. So we have to choose the second point to get the direction of the point. Is that okay? To graph, and this is open circle. To graph the second piece, which one is the start point? 2, -3. So I'm gonna say, okay, here's 2, 1, 2, 3. So here's the start point. It's a closed circle. Now, I don't know the graph going where. Up, down, this side, I don't know. So I have to check what? Second point, which is 4, 1, 2, 3, 4, 5, 4, and 1, 2, 3, 4, 5. Here is the second point. So now I know the graph going where. From this point, going down and keep going down. That's it. See, not connected, but check what here. The same point too. Why? Same point is 1, 2. Both points have 2, x equal 2. What's the condition here? So always pick the condition as a start point. Go ahead, choose any point on the top, choose any point on the bottom. Doesn't matter. Graph this piece separate. Graph this piece separate. Be careful from the sign. If there's equal sign in closed circle, there's no equal sign here. That means it's an open circle. Done. So to graph this one, graph with 3 pieces, you do exactly the same thing. You need to x, find the value of y. We need to get the point with x, y. How many pieces do I have here? 3 pieces. That's me. This dashed line on the first piece. Here's another one. You have what? Second piece. Now tell me, which number I'm gonna put here? Oh, here.
0 and 2.
Check this piece. 0 and 0 start here. And 2 end with 2. So be careful. Okay? So 0, 0. That's what I'm gonna put here. 0, 0. Always the same number. Because this, the point connect with the second piece is the 0. And this piece connected with 2 with 2. Okay? So which number I'm gonna put here? 2 and 2. Check the middle piece. I already have 2 points, so I don't have to worry about which point I'm gonna plug in here. These 2 points exist here. Now let's go back to the beginning. You have a cosine here. So this point should be what? A circle. This point, you have a cosine here. So this point should be what? Circle. Number 2, it exists here. A cosine. So this one is what? Circle. What about the last one? Circle. See, I create the table before I start plugging any number. Now let's go back to the first piece. I have point. What says the condition? -2. I need a number less than 0. He said -2. Okay? With the second piece, do I need number? No, I have 2 points. That's enough to graph any line. 2 points is enough. Now with the third piece, I have 2. I need a number greater than, which is 4. If you choose 5, if you choose 6, if you choose a 3, it's the same thing. Okay. Now everything set up. Next step, we're going to plug in. Plug in these 2 numbers on the first piece. When x is -2, how much is the value of y? -1. Do not multiply with -1. Okay, because there is no x here. If there is x, you're gonna put -2 instead of the x and do multiplication. So when x is -2, y is -1. So the first point is -2, -1. 0. When x is 0, how much the y? When x is 0, how much the y? Also -1. So 0, -1. Is that okay? No problem? Let's jump to the next piece. When x is 0, how much the y? 0 minus 1, which is equal. So it's going to be also 0, -1. Is that okay? 2, plug in 2 where? Here. So 2 minus 1 is going to be 1. So this point is going to be 2 and. Okay. The third piece, plug in 2 here. So maybe -2 times 2 plus 6. -2 times 2, 4 plus 6. So it's going to be 2 and 2. Last number, plug in 4. So it will be -2 times 4 plus 6. -2 times 4, 8 plus 6. Going to be 4 and -2. Okay, so far. Create Google graph. Let's check here. With the first piece, where's the start point? 0, -1. 0, -1. So here is the start point, which is what? It's open circle. Second point, -2, -1. So here is -2. Here's what? So where is the graph going? So just straight line goes to the. That's it. The first piece. Why? Because you see the y coordinate? -1, so it's going to be -1 constant function. Okay? From the first piece. The second piece, I have 2 points, and both these 2 points is a start point. So where's the first one? Is that the same one? So to grab the second point, this one is going to be what? Closed circle now. It's open circle and a closed circle on the same time. Is that okay? Because I'm graphing the second piece. Now this is a closed circle. Where is the other one? 2 and 1. Let's graph 2, 1. 2 and 1. Also what? Closed circle. So the graph going from here to here. That's it. It's not going to go up. Because only between what? These two numbers. So the graph going from here to here. That's it. Now let's grab the next piece. Where's the start point? 1, 2. Let's check. Where's 2 and 2? 1, 2, 1, 2. So here is the start point, which is open or closed? There is open. Second piece, the second point, 4, -2. 1, 2, 3, 4, -2, right? 1, 2. So it's going to be here. Where is the graph? Very big. It's gonna here. Second point, and keep going down. You see, the graph is connected, the two pieces, the first piece and the second piece is connected. The same point. But with the third piece is not connected. Here's this graph. Is that okay? That's it. The slope to figure out the increasing and decreasing. And you set the slope, we need 2 points. So let's say that if we have the 2 points x1, right, and the other point is x2, y2. Now I need to find the slope. In this case, the slope, always they say m equal y2 minus y1 over x2 minus x1. Okay, so we're going to find the slope. So I need 2 points. I'm going to use these 2 points to find the slope. And here's the thing. If our slope is positive number, positive, I'm not going to care about the number. I need positive. I just say positive. So the function is what? That's it, gone. If the slope is what? Negative, what does that mean? If the slope is 0, what does that mean? Okay, so far? Yes or no? Because you're going to help me with finding the slope. But let's look to the graph. We already have the same graph. Okay, number 17. Okay, now, for the first piece, this one is the first piece, right? Can I say number 1? There's the second piece. You see this one? Number 2. The third piece here. number 3, and this is the 4th piece. Four. I'm getting hang of it, so it's fine. I'm gonna do. You got the idea? So name each piece, so I'm not gonna mess up your brain, okay? That's what I'm doing. Now for the first piece, you said we need how many points? 2 points to find the slope. Now give me 2 points from this piece. Look to the, this is point also. Like I don't care, but this is one of the points. So for number 1, this is a point, okay? Which is what? 2 and 1.
-1, I'm sorry.
2 negative 1.
Oh, -2, -1.
-5.
-2 and -1. And the other point, you said what? Look to the graph, because this is not accurate. Look at the graph you have. You said -5 and? -5 and -5. So these are 2 points. Use these 2 points from this piece to find the slope. You're gonna say this is x1, y1, x2, y2. Is that okay? Plug in everything here, but be careful from the side. That's the important part. So plug in here. Y2, that means the slope equal. Y2 is -5 minus Y1 is -1. You see? Be careful from the negative sign because there is negative sign with the formula. Over what? X2 is 5 minus X1 is okay. So it's going to be what? -5 plus 1 over what? -5 plus. And the result is what? -4 divided by, which is equal what? 4 over 3. Yes or no? I told you I don't care about the number. I care about what? Sign. Is that positive number? So what does that mean? This piece is what? Increasing. Now here is the important part. How are you gonna write down this part? How are you gonna write down this piece? It's increasing. How are you gonna write down? I need to write down this piece saying this piece is increasing. How are you gonna write it? Write it down as interval notation. With the x. From this x to this x, the function is increasing. So from the left to the right. Now tell me the x on this point goes where? Wait. The whole piece. You're right. You said -5. Just follow on these 2 points, but this is you picked this point. Someone else is gonna pick -10 and -10.
X is
Fine. From negative infinity, because the x is here as well. Negative infinity and the x is here as well. Positive infinity. So yes, that's the point. We need to write down the whole piece. That means we need to write down all the x value. Right? Be careful. All the x value for this piece. From which point to which point? From negative infinity was where?
2, -1.
-2. Was this piece and until which point? And until -2, just the x value. So from negative infinity to -2, the function is increasing. You get the idea? From negative, I'm just write down the x value for this piece from negative infinity to -2, the function is increasing. Now, what about the second piece? Can I do the same thing?
2 to 0, constant.
You can tell it's constant. But tell me the interval from -2 to where? To 0. From -2 to 0 is constant. If you check it 100%, when you choose 2 points here, and when you find the slope is going to be what? 0. Okay? For the second piece. Now go ahead, practice on the third piece. Pick 2 points and find the slope. So for the second piece, yes, you can tell it's decreasing, but the slope is going to be what? So for the second piece, from where to where? Tell me. Tell me the interval here. From 0 to 0 to 2. The fraction is what? Because the slope is equal to this number. This is for piece 3. For piece 4, have these 2 points. You can choose it and you can tell the slope here is going to be 100% is positive. So this function is increasing. And tell me the interval for this function from where? From 2 to infinity, the function is. Okay, so far?